Hi guys, in this video we're going to look at touching circles. Now there's two types of touching when it comes to circles. The first one is external touching, as you can see here, this is outside. And the other one is internal touching, and again you can see here that this circle is inside the larger circle. So the larger circle, and on the outside the smaller circle is touching, that's external touching, and internal touching you can see here, it's inside that large circle. So couple of rules, it's really straightforward. C1, so circle 1 and circle 2 touch externally if R1 plus R2 is equal to D. So you can see here that the two radii will be in a straight line. And if this R1 plus R2, so radius 1 plus radius 2, is equal to the distance between the centres, then that means they are touching externally. And internally, if we take the larger one here, okay, which is R1, so that's the bigger circle, take away R2, which is this. If the distance between the 2 points is equal to R1, take away R2, then that means they are touching internally. Obviously this R1 radius has to be bigger than the R2 radius. Okay, let's have a look at an example. It says, show that the circles x squared plus y squared minus 2x minus 2y is equal to 0 and x squared plus y squared minus 8x minus 8y plus 24 is equal to 0 touch externally. Now remember from the previous slide, if they touch externally, then R1 plus R2 must equal the distance between the two centres. So the first thing we need to do is work out the centres. Let's get that. So we've got x squared plus y squared minus 2x minus 2y is equal to 0. And I'll come down here and do the other one as well. We've got x squared plus y squared minus 8x minus 8y plus 24 is equal to 0. Now remember how to work out the centre when it's of this form. What we do is we take the x, we halve it, change the sign. Same with the y, halve it, change the sign. So the centre should be fairly straightforward. So the centre here is minus 2, halved is minus 1, change the sign, it is 1. Same for minus 2 here, again it's going to be 1, 1. And therefore we now have the centre. We're also going to need the radius because we're going to have to work out whether the two radii added together is the same as the distance. So let's work that out now. Remember, r is equal to the square root of g squared plus f squared minus c. Okay, so g squared plus f squared minus c. So the radius for this one is equal to, well, we have 1 squared plus 1 squared. We don't have a c here, it's just 0. So we end up with r being equal to root 2. So we have our centre and we have our radius. I'm going to do exactly the same now with this second circle. Again, looking at the x values here and the y values, we're going to change the sign and halve them. So minus 8 halved is minus 4, so it's going to become equal to 4 when we change the sign, and it's the same there. So my centre is going to be equal to, so let's have a look, my centre is equal to 4 here, and my radius is going to be equal to, and it's going to be g squared plus f squared minus c again. So let's put those numbers in. So r is equal to 4 squared plus 4 squared. And we have minus c, which is 24. The c value is this particular value up here. And we're going to square root that. So let's add them up together. We get 16 plus 16, which is 32. So r is equal to the square root of 32, take away 24. And 32 take away 24 is 8, so we get r is equal to root 8. And we can simplify that by saying that r is equal to root 4 by root 2. Remember that there, 4 times 2 will give me the 8. And we know what root 4 is, it's 2, so r is equal to 2 root 2. Okay, so we have the radius of the first one, we have the radius of the second circle, and we now need to work out the distance between the two centres. So let's just write them down here. So the first centre is 1, 1. The second centre is 4, 4. We're now going to label them before we stick them through the formula. So we've got x1, y1, and we've got x2, y2. And remember that the formula for the distance is equal to x2 minus x1 all squared plus y2 minus y1 all squared square rooted. So we're going to stick those numbers in. We get d is equal to, and it's 4 minus 1 all squared plus 4 minus 1 all squared. And don't forget to square root that. This is equal to 3 squared plus 3 squared, guys. square root, and I hope you can see that d is equal to 9 plus 9, which is root 18. Now root 18 we can actually break up as we did before. Root 18 is the same as root 9 times root 2. And we know the answer to root 9. Root 9 is 3, so this is going to be equal to 3 root 2. So the distance between the two centres is equal to, let's put d here, is equal to 3 root 2. So we need to show that they touch externally. So for external touching, what we know is that R1 plus R2 must be equal to D. Our R1 is root 2, that's from here. My R2 is going to be 2 root 2 here, so plus 2 root 2 must equal the distance between the two centres, and the distance between the two centres we've calculated down here to be equal to 3 root 2. And if we have one lot of root 2 plus 2 lots of root 2, that means we've got 3 lots of root 2 on the left-hand side is equal to 3 lots of root 2 on the right-hand side. Therefore, they are touching externally. And we are